This is Mission Control reporting live on May 27th. We are located at the Launch Center in Merritt Island, Florida. When the group clears the launch tower, we will transfer over to our space station in Houston. Here's an interview with one of our astronauts going to Mars.
Hello, I am Anna and this is our astronaut Oprah. At this moment, Oprah is wearing her spacesuit for educational purposes. However, when she does not need to wear her spacesuit, she can wear her regular cotton clothing inside the domes, or here on Earth. For her spacesuit, she has her space coat, which keeps her warm in the cold vacuum of space. She has her space helmet, which helps her to breathe, and she has glasses, so her eyes are protected from the harmful light rays in space. Now, Oprah, can you tell us about what you have done to become an astronaut?
Well, Anna, to be able to travel to Mars, or be an astronaut in general, it is necessary to be educated properly.
What kind of schooling do you need to become an astronaut?
From experience, all astronaut candidates must have earned a bachelor's degree from an accredited institution in engineering, biological science, physical science, or mathematics. An advanced degree is desirable. Candidates also must have at least 3 years of related, progressively responsible professional experience, or at least 1,000 hours of pilot in-command time in jet aircraft. Astronaut candidates must pass the NASA Long-Duration Space Flight Physical. Many jobs are available that can expand your scientific knowledge. It can take many years to finish all of the schooling that is wanted and needed when it comes to being an aerospace engineer or working in the space program.
We just got video of Oprah during her takeoff to Mars.
From my perspective, she's off to a wild start.
To infinity and beyond.
Blast off.
To prepare for takeoff, there are many trainings. This is an example of a practice run that did not go smoothly. Transfer over to Houston. This is Mission Control, now located at the Lyndon B. Johnson Space Center in Houston, Texas.
Hello, I am Professor Wolf, and I'm here with Professor Kaczynski and Professor Johansson. And we are here to tell you about life on Mars.
Laws on Mars will be the U.S. Constitution until more people have moved to Mars, and then we'll create our own laws and our own Constitution.
As for religion, each astronaut could have their own religion so long as it does not interfere with any of the other astronauts or themselves, and so long as there is no danger from the religion.
It is the same way with culture as it is with religion. As long as the group or culture you participate does not and will not interfere or harm others, it will be allowed on Mars. Barter or trade is necessary for long-term space travel. While doing research, I found that a different NASA-ESA barter arrangement could be made that includes the following. ESA and NASA's exploration plans. It would not upset an apple cart that has been designed for many years. It adds value to NASA's plans. It involves distinct elements to reduce managerial and political complexity, uses ESA's strengths, does not damage U.S. interests, such as subsidizing European competition with U.S. commercial space, involves work that ESA would want to do, fitting their long-term goals and using their industry. As heard in the text-based example, ESA stands for European Space Agency.
This is America making a barter with Europe.
Bartering is also what helps provide materials for a safe shelter in space.
Did you know that there are more ways to live on Mars than in just domes?
There is?
And from research, I found the Mars Ice Home, a large inflatable dome that is surrounded by a shell of water ice.
Oh my gosh.
The idea came from a team at NASA's Langley Research Center that used resources on Mars to help build a habitat. This habitat helps protect our astronauts from high-energy radiation.
Our astronauts could live there.
The dome allows light to pass through ice and surrounding materials, so they will have light. But for this mission, our astronauts will be living in domes.
Protecting the astronauts on their way to Mars is important. It's also equally important to make sure they are 100% safe when they reach Mars to live there, healthy to begin with. According to Real Martians, it says, the risk of health effects can also be reduced in operational ways, such as having a special area of the spacecraft or Mars habitat that could be a radiation storm shelter, preparing spacewalk and research protocols to minimize time outside the more heavily shielded spacecraft for habitat, and ensuring that astronauts can quickly return indoors in the event of a radiation storm.
What is radiation?
Well, Shayla, radiation is the emission of energy as electromagnetic waves, or as moving subatomic particles, especially high-energy particles that can cause ionization.
Wow.
Radiation is not the only danger in space. There are also dust storms and personal health that we need to be aware of.
What the heck is a dust storm?
A dust storm is a meteorological phenomenon that the storms arise when a gust front or other strong wind blows loose sand and dirt from a dry surface.
To make sure that astronauts are 100% safe, communication between Earth and Mars has to stay stable. All communication between Mars and Earth go through satellites. Because of the distance, though, there's a substantial delay, which means it can take between 3 and 22 minutes for the information to reach the other.
That's a long time.
Fortunately, yes. However, fortunately, there would be other ways to get information to each other. There's no limitations to email or texting with Mars residents between Earth. It'll just take at least 6 minutes for you to get your reply. Both voicemail and video messages are also easily workable options. Also, with communication is health. The health of astronauts is very important. Even before space travel, all astronauts must start out in prime health, or space travel is very dangerous for them. On Mars, for now, there is no doctor. Later on, though, we hope to have a full hospital for any illnesses that may appear. Hopefully, the illnesses that we are already aware of will not appear on Mars with the right precautions.
How are you going to breathe on Mars?
Oxygen is needed for humans to breathe on Mars. There will be a recycling system to take back carbon dioxide and turn it into breathable air. It is said from NASA, in addition to exhaled CO2, people also emit small amounts of other gases. Methane and carbon dioxide are produced in the intestines, and ammonia is created by the breakdown of urea in sweat. People also emit acetone, methyl alcohol, and carbon monoxide, which are byproducts of metabolism in their urine and their breath.
What are we going to do with all our extra materials on Mars? What are we going to do if we start to run out of materials? Well, NASA created a small trash compactor. It compacts trash smaller than a square foot. So trash, food wrappers, wet wipes, and even old clothing can get recycled.
Wow!
This squishes down all the trash and it heats it up to about 150 degrees. The result is like a hockey puck tile, like this one, that can be used for radiation shielding. And there's a valuable byproduct to it too. Any water that's left in it will boil out, and then we can recondense that water for reuse. Water is precious in space, so we want to recover as much water as we can from the trash.
You can recycle water from trash? Ew.
All I knew about water was that water from Mars will come up through our water pump. Our water pump will receive water from the ancient lake located on Gale Crater, which we live. Water can also be extracted from the planet's soil. According to Mars 1, water can be extracted from the soil. The rover will select the location for the settlement, primarily based on the water content in the soil. We expect this to be at a latitude of between 40 and 45 degrees north. Water extraction will be performed by the life support units. The rover will deposit soil into a water extractor in the life support units, and the water extractor will heat the soil until the water evaporates. The evaporated water will be condensed and stored, the dry soil expelled, and the process repeated to extract more water.
What are we going to eat on Mars? Well, the main diet for the astronauts will be freeze-dried foods such as freeze-dried fruits, vegetables, and also the fresh food that we grow in our domes.
What will happen if we run out of food?
Well, when the astronauts land on Mars, there will be storable food from Earth waiting for them to use. The storable food from Earth will only serve as emergency rations, which means the astronauts will try to eat as much fresh food that they produce on Mars as possible.
Here at NASA, we built a dome model and a full dome structure to scale to show you what life on Mars will look like after our astronaut reaches the red planet. This is our energy dome, which the water pump stays in to pump water out of the crater. This is our water pump. This is where we get water from Mars's soil.
This is our battery. This is where we get energy to power our domes.
This is our central heating system for all of our domes.
This is our generator. This is how we power our domes.
This is our plant dome, where oxygen is made and where plants are grown. This is our greenhouse dome.
This is where we get our fresh food and oxygen from.
This is our research dome, where we communicate back with mission control in NASA.
This is our research dome. This is where we do all our research about Mars.
This is our living dome, where we eat our astronaut food and we sleep. After walking through our airlock dome and into our living dome, the first thing you'll see is our kitchen. Let's go! So, in our kitchen, we like to prepare our food. We have astronaut food and fresh produce from our greenhouse. This is our dining room, where our astronauts eat our astronaut food and our plants from our greenhouse. This is our living room. We like to hang here. Welcome to our bathroom. It's red like planet Mars. Upstairs is our loft. This is where we sleep.
And this here is another bathroom in our Mars dome.
This is our airlock dome, which gets rid of the toxic air from Mars's atmosphere and creates healthy oxygen for us to breathe. I'm astronaut Oprah, and I made it to Mars. Also, I found an alien. This is our central heating system for our whole... That didn't make sense. Hey, Biscuit! Hey, Biscuit. Have at least 3 years of related progressive... This is our research dome, where we research stuff about Mars. Hey, Biscuit! Hey, Biscuit! Hey, Biscuit!
watch this now. Hello, I am Professor AJ from Mission Control, and this is our astronaut in Oprah.
This is our astronaut. Oh, sorry.
This is our astronaut, Oprah. She is wearing the latest.
Wait, I have a question. I have a question. Can you see my face through here?
Yes.
So you can see how stupid I look?
It's
Okay.
a clear bowl.
It's so hot. Okay, ready?